Hi, everybody, and welcome. This is Jeff Delto with Convergence Training, a Vector Solutions brand. And we're back on a little recurrent discussion on issues related to reliability, maintainability, and maintenance with Dr. Klaus Blake. He's the director of the Reliability and Maintainability Center at University of Tennessee, also known as the UT-RMC. Klaus, how are you today?
Doing great, Jeff.
Cool. Thanks a lot for joining us. And today we're going to discuss predictive maintenance and condition-based monitoring. And I wonder if we could just have you explain what each of them are and what's the difference between the two of them.
Well, I thought I'd start out and maybe kind of read the two sentences that are the predictive maintenance definition from SMRP.
Sure.
That's probably what most people look at, and then I'll say a few words beyond that to tie those together. Kind of the formal definition from SMRP is predictive maintenance, or often PDM, is an equipment maintenance strategy based on assessing the condition of an asset to determine the likelihood of failure. The key is the likelihood, it's not an exact time.
Right.
The likelihood of failure, and then taking appropriate action to avoid failure. The condition of equipment can be measured using condition monitoring technologies, statistical process control, equipment performance indicators, or through the use of human senses. Now, again, the key thing here is note that PDM, or predictive maintenance, only indicates the likelihood of failure. It kind of puts you in a window of time that you can go do something about it. Now, condition-based maintenance, or some say condition-based monitoring, is performed only when it's required, meaning that you're doing the condition-based monitoring all the time, but it triggers when you actually go do the maintenance. So, and it's usually in response to a deviation from a normal condition of the machine. So CBM uses real-time data typically and looks at trends regarding the asset's health, and that indicates when to take action by comparing historical data to current data, and then it watches predetermined limits, and when those are passed, there's your opportunity to do that maintenance. You kind of do it when you need to do it and not before that. So in summary, using CBM, or condition-based maintenance, you should only be performed when specific indicators show signs of decreasing performance that can lead to failure. So one is, to me, a lot more specific, and the other one, it kind of gives you a window of time.
All right, great. Thanks. That makes a good explanation. Well, could you give us an example of each? One example of predictive maintenance and one example of condition-based maintenance or monitoring?
Sure, and they somewhat work with some of the same technologies. So if you're looking again at predictive maintenance, and examples of predictive maintenance are pretty much all the well-known technologies that were always talked about, like ultrasound, vibration analysis, infrared technology, motor circuit analysis, and I'll throw in oil analysis. Now, condition-based maintenance uses sensors and also all these same technologies as needed to trigger maintenance with enough lead time to avoid the failure again. Now, the difference is that measurement is typically continuous and can be done while the equipment's running. So that's a big differentiator versus operators using the technologies on PM routes.
Gotcha.
So CPM uses strategically placed sensors to monitor things like temperature, pressure, flow, and so on, in addition to doing the predictive technologies. And preferably, again, it's done in real time, so you can get to that stuff as quickly as possible. So you can do condition-based maintenance with just PM technology routes, but when you don't do it continuously, you're obviously increasing that window of opportunity that it's going to be less effective in detecting the problem. So if you don't do it, the monitoring continuously, you might do too much maintenance or not enough maintenance. You're still working within a window on just doing technology routes.
All right, great. And so what would be your recommendation for when to use predictive and when to use condition-based monitoring or maintenance?
Well, the answer really comes down to which approach is more cost-effective. As stated earlier, condition-based monitoring is performed when the asset's running, so production is not disrupted. So that's a big benefit. But at the same time, a CBM also avoids doing too many maintenance interventions, which can cause other issues due to human error, poor maintenance practices, and more. So CBM, obviously is going to be a little bit more expensive and requires a little more analytical skill set, but sensor costs have come down along with increasing wireless capabilities and computing powers there at a lower cost. So a lot of the things are right for taking more advantage of that more recently. And I always like to say the best solution is the simplest one that works. So to set up your program, put together a matrix of assets versus predictive technologies, and take a look at what can be done, what should be done, and what do you have resources to do so you get the biggest bang for the buck. Then select the failure modes that can be detected by the condition-based monitoring or maintenance, and then align them with feasible technologies and decide what's economical. Maybe PM technology routes are worth it because of the risk involved or less risk involved, but in certain percentages, you want to do complete condition-based monitoring real time all the time. So it comes down to a cost-effective solution at the end.
Including apparently use of risk management at times for
Absolutely.
making that decision. Okay, great. You mentioned some of these sensors have gone down in price. Do you anticipate that will continue?
Oh, I think so, absolutely, and especially with a lot of the new stuff. I mean, the latest buzzword. I was one of the keynotes at OSI Soft Conference in April in San Francisco, and probably half the vendors there were either displaying or talking edge computing. So that's really bringing all the computing power down at the local level, and that's going to enhance it even more. Yeah.
Gotcha. Cool. And any metrics or things people should be aware of to see how they're doing in this area?
There's a lot of things that could be done, and maybe I'll just mention a few cautions. Let's say if you're starting out in PDM or hopefully condition-based maintenance, I would, this is if you're starting out, separate your technology compliance from your total maintenance compliance. So again, meaning I'll just make up an example. If you have 1,000 maintenance tasks that need to get done that month, typically 100 of those might be predictive technology related, and 900 everything else. So you can still be 90% compliant and not do any of your technologies. And that's what unfortunately I see in a lot of companies that are struggling.
Mm-hmm.
They're not doing their predictive technologies. And from surveys of companies, mine and others, about 60 to 70% are using the key technologies that were mentioned, all the predictive technologies earlier, but they're not being used on enough assets. So again, the resource constraint, they might be doing the technologies, but maybe on 20% of the assets, maybe not always the critical assets. And there's insufficient root cause analysis once they find a problem. So they don't take it to the next step, whether that's resource or skills, that's probably not the right discussion for this. Also, about 60% of companies don't feel that the predictive program is working well. That's a big one. And my data shows that over 75% of North America is not doing enough finding and fixing. By finding, I mean using your predictive technologies, finding an issue, but then also driving it to root cause, and then putting out the work orders to do that. And 75% of North America is not there, and that's huge. And if you're highly reactive, let's say over 60%, which gets to about the bottom quartile, your maintenance costs are 6 to 7 times higher than the average top quartile facility in North America.
Wow.
And you get there by finding and fixing. So if you're not doing that finding and fixing, if you look at a long enough period of time, you're just fixing those same errors over and over again.
Mm-hmm.
And what Einstein's old definition, doing the same thing over and over again, expecting different results, that's insanity.
Correct.
Well, I like to say doing the same maintenance over and over again over a long period of time, that's maintenance insanity. And that's what 75% of North America is doing right now.
All right, great.
So maybe a closing comment. It's probably important to say that keep in mind that the job of reliability and maintainability is not just to fix things when they fail. The goal is to maintain the assets in such a way that the failure is engineered out, avoided, or the consequences of failure are avoided. Or simply stated, reliability and maintainability needs to be designed in. So again, it's a designed-in function if it's done right. So.
Right, and we talked about that in our previous discussion. Well, if I could add one opportunity for a final word, there's a lot to learn here for people. Could you tell us a little bit about the UT RMC and your RMI certification?
The RMIC, it's a reliability and maintainability implementation certification. Basically 6 professional development classes. 3 can come from our training partners, Red Vector being one of those. So you can take 120 hours of Red Vector training, 40 hours per class of online. That counts as 3 classes. 3 classes come from us. You do a project at the end, not a white paper, but a measurable deliverable with real results back to your facility. And that certifies you for the RMIC certification from UT College of Engineering.
All right, great. Well, thanks again, Klaus. Well, maybe we'll do this again next quarter if you're free. I already got some ideas off this, and we appreciate your time. And tell Chris we said hi.
But we'll do. Thanks, Jeff.
All right.